Deep beneath the majestic Swiss Alps lies an engineering feat so audacious, it redefines what's possible: the Gotthard Base Tunnel. Stretching an astonishing 35 miles, it's not merely the world's longest railway tunnel, but a silent testament to human ambition. For centuries, the Alps have been a formidable barrier, isolating communities and hindering trade. This tunnel was envisioned as a permanent, elegant solution, a direct, high-speed link forged through solid rock. It's a marvel that would forever alter the landscape of European travel and commerce, transforming a vision into a subterranean reality. The idea of a direct route through the Central Alps has captivated engineers for generations. The existing mountain passes and older railway tunnels, while impressive for their time, struggled with steep gradients and limited capacity. As Europe's economy grew and environmental concerns mounted, the need for a modern, efficient, and sustainable transit artery became paramount. The Gotthard Base Tunnel was conceived to flatten the Alps, providing a near-level route that would dramatically cut travel times and allow for heavier, faster trains, bridging economic centers with unprecedented ease and efficiency. The Alps, while beautiful, are an engineer's nightmare. Their geology is a complex tapestry of metamorphic rock, fault lines, and immense pressures. Drilling through them meant confronting extreme heat from geothermal activity, rock bursts, and unexpected water ingress. The sheer depth of the tunnel, with over 7,500 feet of rock overhead at points, created unimaginable forces. Every inch of progress was a battle against nature's raw power, demanding innovative solutions and unwavering resolve from the thousands of workers who ventured into the mountain's heart. Initiating a project of this magnitude required monumental resources and commitment. The Gotthard Base Tunnel wasn't just a tunnel, it was a nation-building endeavor. The total cost spiraled to an estimated $12 billion, a figure reflecting the complexity, duration, and sheer scale of the undertaking. From conception to completion, the project spanned decades, with the active construction phase alone consuming 17 years. It stands as one of the most expensive and time-consuming infrastructure projects in modern history, a testament to Switzerland's long-term vision and engineering prowess. The cornerstone of conquering the Alps lay in the deployment of tunnel boring machines, or TBMs. These colossal machines were not just tools, they were mobile factories designed to chew through rock with relentless efficiency. Custom-built for the Gotthard geology, they represented the pinnacle of underground engineering at the time. Each TBM was a mechanical titan, over 400 meters long, comprising a rotating cutter head, excavation support systems, and a series of trailing mechanisms for segment installation and debris removal. These machines were the undisputed heroes of the subterranean frontier. The Gotthard TBMs were truly mechanical giants, each weighing approximately 3,000 tons, roughly the weight of 50 Boeing 747s. Affectionately nicknamed Sissy, Heidi, Gabby I, and Gabby II by the crews, these machines worked tirelessly, boring twin tunnels simultaneously. Their sheer power allowed them to advance meters each day, a rate unthinkable with conventional drilling and blasting methods in such challenging conditions. Their intricate design allowed for continuous operation, integrating rock excavation, tunnel lining, and material transport into one seamless, albeit enormous, process. The journey through the mountain was an epic geological encounter. The TBMs faced an astounding 73 different types of rock, from soft, crumbly shale to granite harder than steel. Each geological formation presented unique challenges, requiring continuous adjustments to boring parameters and cutter head maintenance. The TBM's massive rotating disc, armed with hardened carbide cutters, chipped away at the rock face, pulverizing it into manageable fragments. This excavated material was then efficiently transported away, making space for the continuous forward march of the tunnel. It was a relentless, grinding process that demanded precision and power. To accelerate the colossal 17-year construction timeline, engineers employed a brilliant strategy: the multi-portal approach. Instead of drilling solely from the north and south ends, intermediate access tunnels were dug from various points along the mountain's flanks. This allowed construction crews to tackle the main tunnels from 5 different access points simultaneously, effectively multiplying their progress. This innovative logistical approach significantly reduced the overall construction time, turning a project that could have taken a generation into one completed within a manageable timeframe, pushing the boundaries of construction methodology. As the tunnels delved deeper, ambient temperatures rose dramatically due to geothermal heat. At its deepest points, the rock temperature reached over 45 degrees Celsius, 113 degrees Fahrenheit. To ensure workers' safety and equipment functionality, sophisticated cooling and ventilation systems were imperative. Chilled water was circulated through the tunnels, and massive fans continuously pumped fresh air in, extracting hot, humid air. This constant battle against subterranean extremes was as crucial as drilling itself, highlighting the complex environmental controls needed to sustain human activity deep within the earth. Constructing 35 miles of tunnel meant removing an astonishing 28 million tons of excavated rock, enough to fill 8 Great Pyramids of Giza. This massive volume of material, along with the constant supply of concrete segments and equipment, required a highly sophisticated internal logistics system. Custom-built railways and conveyor belts stretched for miles within the tunnels, moving materials in and out with clockwork precision. Remarkably, much of the excavated rock was recycled on-site, crushed and used to produce concrete for the tunnel lining and other construction materials, minimizing environmental impact and logistical strain. Behind every ton of steel and every meter of board rock were thousands of dedicated individuals. Geologists meticulously mapped the mountain's secrets, engineers designed solutions for unprecedented challenges, and skilled miners and technicians operated the colossal machinery. This diverse international workforce, hailing from over 60 nations, shared a common goal: to conquer the Gotthard. Their commitment, resilience, and ingenuity were paramount, demonstrating that even with the most advanced technology, the human spirit of collaboration and problem-solving remains the driving force behind monumental achievements. After 17 years of relentless drilling, the moment arrived. On October 15, 2010, at exactly 2:17 p.m., the final rock barrier was ceremoniously broken, connecting the northern and southern sections of the eastern tunnel. The air was filled with cheers, relief, and profound satisfaction. It was a historic moment, not just for the Gotthard project, but for engineering globally. This breakthrough symbolized the culmination of decades of planning, years of arduous labor, and the successful application of groundbreaking technology. The Alps had finally yielded, opening a new pathway through its ancient heart. The Gotthard Base Tunnel is far more than two simple tubes through a mountain. It's a complex, redundant system designed for maximum safety and operational efficiency. Every 325 meters, cross passages connect the twin tunnels, serving as emergency escape routes. 2 emergency stations, complete with state-of-the-art ventilation and fire suppression systems, are strategically located within the tunnel. Redundant power supplies and sophisticated monitoring systems ensure continuous operation and immediate response to any incident. This meticulous planning transforms the tunnel into a secure, self-sufficient ecosystem, prioritizing passenger and freight safety above all. On June 1, 2016, the Gotthard Base Tunnel officially opened, marked by a grand inauguration ceremony attended by European leaders. The first commercial passenger and freight trains heralded a new era. Today, the tunnel operates round the clock, a seamless artery beneath the Alps. It handles an astounding volume of traffic, significantly enhancing the flow of goods and people across the continent. This operational efficiency is a direct result of the immense engineering effort, allowing hundreds of trains to pass through daily with unprecedented speed and reliability. The Gotthard Base Tunnel has profoundly reshaped European transportation. It has become a vital link in the trans-European rail network, drastically cutting travel times between major cities like Zurich and Milan, now reducing the journey to just 3 hours. But its impact extends far beyond passenger convenience. By providing a flat, high-capacity route, it facilitates the shift of heavy freight from road to rail, reducing congestion on scenic alpine routes and increasing the efficiency of supply chains across the continent. It's a strategic corridor for European integration and economic vitality, a game-changer for international logistics. Beyond its economic and logistical benefits, the Gotthard Base Tunnel is a triumph of environmental stewardship. By enabling the shift of heavy road freight onto electric trains, it significantly reduces carbon emissions and air pollution across the Alps. Estimates suggest the tunnel contributes to an annual reduction of 900,000 tons of CO2, making it a cornerstone of sustainable transportation in Europe. It preserves the pristine alpine environment from the noise, exhaust, and wear and tear of thousands of trucks, demonstrating that megaprojects can coexist with, and even benefit, ecological goals. The Gotthard Base Tunnel stands as a monumental testament to human ingenuity and perseverance. It exemplifies how vision, combined with cutting-edge engineering and a relentless commitment to overcoming obstacles, can achieve what once seemed impossible. This underground marvel is more than just concrete and steel, it's a symbol of collaboration, innovation, and a nation's resolve to connect. It inspires future generations of engineers and demonstrates the profound impact that such ambitious projects can have on our world, both beneath the surface and above. As trains continue to glide through the Gotthard Base Tunnel, it silently reinforces its legacy as a global benchmark for civil engineering. It's a testament to patience, precision, and the courage to dream big. The tunnel has not only redefined travel through the Alps but has also set new standards for safety, efficiency, and environmental responsibility in large-scale infrastructure. Its creation is a story etched in rock and steel, a story of an underground engineering marvel that truly reshaped a continent, proving that with unwavering determination, humanity can indeed move mountains.